Ta-ta! I can't reproduce the problem I have, so and this is the ship select, which is connected to the output enable of the data thing. And see how small this signal is. This is supposed to be address line 1, which is normally changes for every clock cycle or every output enable. So you can see I'm measuring down here, and let's pick it up and see what happens. Now it's up in the air, you can see. Just hooked it up there, and the signal is back to normal, or something that looks normal. So look what happens when I try to program it. And then we're back there. Okay, I think I found something. If you look on this side, you can see that here is the input for the direction of this transceiver, if it's going to send this way or this way. This pin is grounded, and that means the direction is this way for the data. So it goes out of the system into the Videopac. And this is the opposite, because we are going to get address in, so therefore we need to have it at high, but here it's connected to ground, so fix that, see what happens. Okay, I did a change, and now it looks better. You can see we have a full signal there. Basically I had two drivers, one in the Videopac and then one here though. Like this. Let me just show you. This is the signal from the address latch coming from the Videopac. So you see the middle there, the white one. And if I move it out on A9, so that was A0 right here, you can see it's more rounded. And here is A10. And the reason for that is this is port pins, port 2 actually, of the Intel 8048. And these here are a completely different driver. So that's why. But anyway, when I connect on the other side of my bus transceiver, you can see that I square up a lot. So it's a bit noisy, but it works. So yeah. So, and if I move this over here, the data 0, we can see that it's a lot of strange stuff going on, but basically when the output enable is low, that means the CPU wants data. You can see that it's stable at this point anyway. And you can also see that it's supposed to be completely high, nothing in between. And we're back. So I mixed up the red and yellow address lines there. Okay, so let's talk memory map. Now we have it running. I haven't done anything to the image file, so now it's, even though I haven't done that, I can do a reset, I can press 1 and it starts. So what I've done, I have removed A10 from here and I moved the black one over here. So now we have a working system. However, if I move everything back which it's supposed to be, you can hear now the computer crashed, do a reset, it's no longer working. So what can we do without doing this? Okay, first of all, the ROM image is supposed to start at 400, but it doesn't. It starts at 0. So how is that possible? Well, when you remove that A10, then it starts at 400 hex. So what is 400 hex? Well, 400 hex is actually 1K. And this is reserved for the internal program. And this is like a no-go. So if you remove A10, then what happens then? Well, A10 is 2 to the power of 10, which is the same as 1024. or 1 kilobyte. So, or 1K addresses, or words if you like. That means that the 1K marker or address is no longer active for us. That means if you are here or here, doesn't matter. You're still reading the same data because it's not connected, right? So what they do is that they use the next address line, which is supposed to jump from this area to this area. But instead it's used to jump from this area to this area in the ROM, because the A11 is now the one flipping the 1K. But in the memory map it's a bit different, so so the program has to jump higher than before, so the code is taking care of that. So, but what we can do then, since this part is in both of these two and this part is in both of these two, we just copy this data in here and this data here, and then we have mirrored these two data, 2K data. So yeah, so that's what I'm going to do right now. Okay. Oops, it just dropped in there. Maybe I should make this idiot proof. So, find a knife. Try to get it out of there. So, there you go. So yeah, let's plug it back in then. This. Let's try this again. Yeah, it's complaining. Now it's not complaining anymore. So, Sharkbin, which was another game by the way, is the file that I have now. And you can see it goes to 800, that means 2K. And we can also open it, but then I have to find it first. That's why I like to have the... every time I pull out the memory card, this goes away. And so does also this window, but this program doesn't go away. So, but you can see Sharkbin is now 2K. Now I'm in Shark. Remove everything. Everything, go to the SH, which is the original game. And now we are at 0. Let's take down to 400. That's the first K. So we're supposed to mirror this up to 800. There. And copy into Shark. Remember, this is the first K. So let's see. We paste it twice, one time, second time. So now it's supposed to go to 800. And it does. And now let's continue copying from 400. So let's mirror that also in the upper part, right? Now I'm taking this one and putting it here and here. That's what I'm doing because my memory chip is one-to-one with the bus. So the memory map of the computer will be the same as the RAM. So copy twice there, save it, Control S, wait a little bit, take out the card, insert, and plug the power. Check that the LEDs are lighting. If not, there might be something wrong. Doesn't look very good, but when I press reset now, ta-da! It works. And the address bus is one-to-one, as you can see. So, does it work? Well, I have to start the game first. Let's try play it. Haha. Yeah, I think I have something on the lens. There you go, it was out of focus. Oh, there it goes, bad. Reset. I don't know what. It's a breadboard, so it's bad connections. Hey, look. Turn out into this guy. I think you have to press a button. You can turn these blocks into the ship, so yeah. And continue playing. So another thing you can consider also is to use bus exchange. So you have like a device that exchanges pins for you. But I think the copying in the memory is very nice. So, and I'm going to go for an A10 128 with a 64 pins. And from what I hear, it's possible to drive that memory directly. So if that's possible, then you can copy into the memory really fast and do memory operations really fast. And then I mean really fast. And then you just turn off that alternate peripheral function in your A10 and it will release the bus, I think. So, thank you very much for watching. I hope to see you another time. We'll do some more research on this. Now I also found Mr. Daniel Boris, I think. There you go. He has also a manual, so really nice. Daniel Boris, 98. Great. Here he talks about port 1. Remember in a previous video we were talking about what was happening to these pins. So look, P14, that was the RAM. So yeah, I will end it there. So thank you very much for watching. Bye bye.